air was blown into a balloon such that the volume V in centimeter cube increased at the rate of 2 times into bracket 100 minus t squared centimeter cube per second after t seconds. If the volume is 5 centimeter cube at time t equals 0, find the volume of the balloon when t equals 3 seconds. So the volume was increasing at a rate of 2 times into bracket 100 minus t squared. It means that dv dt equals 2 times 100 minus t squared. So let's multiply both sides by dt. So times dt, this side 2 times dt, so that this dt and dt cancels. Then this implies that dv is equal to 2 times 100 minus t squared dt. So let's go ahead and multiply. So dv is equal to 2 times 100 is 200 minus 2 times t squared becomes 2t squared dt, all of that times dt. So if we take integral of both sides, then we can get the value of n. So v is equal to integral of into bracket 200 minus 2t squared dt. So let's go ahead and do the integration. So v of t is equal to, if you integrate 200, you get 200t minus, if you integrate minus t 2t squared, you add 1 to the square, so it becomes t exponent 3 divided by 3. So this becomes minus 2 over 3 times t exponent 3. Then since this integral has not got any element, then we need to add the constant of integration c. However, the question says that at t equals 0, the volume is 5 centimeter cube. So we need to find v of 0. V of 0 means that wherever we see t, we replace it with 0. So this is equal to 200 times 0 minus 2 over 3 times 0 cube plus c. So v of 0 is equal to 200 times 0 is 0 minus 2 over 3, 0 cube times 2 over 3 becomes plus minus 0 plus c, and therefore v of 0 is equal to c. However, the question says that at t equals 0, the volume is 5 centimeter cube, and therefore v of 0 equals c, which is also equal to 5. This implies that c is equal to 5. So since c is equal to 5, we can then put 5 back into this equation to find the original volume. So v of t equals 200t minus 2 over 3t cubed, then plus 5. The second part of the question says we should find the volume of the balloon when t equals 3 seconds. So all we need to do is to find v of 3. V of 3 is equal to, wherever we see t, we replace it with 3. So this is 200 times 3 minus 2 over 3 times 3 cubed, then plus 5. So this is equal to 200 times 3 equals 600. Then let me bring this plus 5. So plus 5 minus 2 over 3 times 3 cubed is 27. So times 27. So 600 plus 5 is 605 minus 2 times 27 divided by 3 is 9. So minus 2 times 9. So this is equal to 605 minus 2 times 9 is 18. And 605 minus 18 is equal to 587 centimeter cube. The graph of f of x equals x squared. How does it look like? This graph looks like this. This is the graph of f of x equals x squared. But if it is x squared plus 3, it means that the graph has been shifted on the positive y-axis by 3 units. Let's come to the curve. The curve is g of x equals x plus 1. The gradient in this case is equal to 1. It means that this graph looks like this. This is the graph of g of x equals x. It looks like this. So the graph of g of x equals x plus 1 means that the graph has been shifted on the positive y-axis by 1 unit. So this graph will look like this. So let's then go ahead and sketch these two graphs of g of f of x and g of x. So let's go ahead and sketch the curve. We said it had been shifted on the y-axis by 3 units. So the curve will look like this. And this is the curve of f of x equals x squared plus 3. Then now let's go ahead and draw the straight line. G of x equals x plus 1. We said it had been shifted by 1 unit on the positive y-axis. So that will look like. So this is the line g of x equals x plus 1. So now you see that at this point, which is x equals 2, is the point where the curve and the graph touches each other. And then the question says that we should find the region of space bounded by x equals 0, which is this point, to x equals 2. So you see that the required region that they are asking us to find the area is this region. So now you can see that g of x, that function f of x, lies on top of g of x in this region, and therefore the area A is equal to integral of the lower limit is 0 to 2 of the function of f of x, which is into bracket x squared plus 3 minus g of x, which is into bracket x plus 1, then all of that dx. So A is equal to integral of 0 to 2. Let's remove this bracket. So it becomes x squared plus 3. The minus 1 times x is minus x. Minus 1 times 1 is minus 1. Bracket close. Dx. So A is equal to integral of 0 to 2 of x squared plus 3. 3, so first is x squared, then minus x. Then 3 minus 1 is plus 2 dx. So let's go ahead and do the integral. A equals, if you integrate x squared, you get 1 over 3 x cubed. And if you integrate minus x, you get minus 1 over 2 x squared. Then if you integrate 2, you get plus 2x. All of this is evaluated as 0 and 2. So A is equal to, I want to put in the upper limit. The upper limit becomes 1 over 3 times 2 cubed minus 1 over 2 times 2 squared plus 2 times 2 in one bracket minus 1 over 3 0 cubed minus 1 over 2 times 0 squared plus 2 times 0. So area A equals 2 cubed is 8, so this becomes 8 over 3. Then minus 2 squared is 4. 4 divided by 2 is 2. So this becomes minus 2. Then plus 2 times 2 is 4. Plus 4. That is for this side. Then as for this side, it will throw out 0. So this becomes minus 0. So area A equals 8/3. Then minus 2 plus 4 is 2. So plus 2. So this 2 can also be written as 2/1. So let me multiply both the numerator and denominator of this fraction by 3. So times 3/3. So area is equal to 8/3 plus 2 times 3 is 6, 6/3. So 8 plus 6 is equal to 14, and therefore the area A is equal to 14 divided by 3. Or 14 divided by 3 is equal to 4.67 squared units. The velocity v in meters per second of a body moving in a straight line from a point O at any time t seconds is given by v equals 24t minus 3t squared. A. Find the acceleration at any time t. And then B. Calculate the distance from O at the end of 3 seconds. So, from the question, the velocity v of t is equal to 24t minus 3t squared. So, acceleration is equal to dv dt, because acceleration is velocity over time, and this can also be written as v prime of t. So we need to find v prime of t. That is just to differentiate v of t. So if you differentiate 24t, you get 24 minus. If you differentiate minus 3t squared, it becomes minus 6t. So therefore, the acceleration A is equal to 24 minus 60. Then the second part is calculate the distance from O at the end of 3 seconds. Now we know that velocity is the same as or is equal to distance, which is dx, then over time dt. So to find x, so let's multiply both sides by dt. If you multiply here by dt and here by dt, it implies that this dt and dt can cancel out. So dx is equal to v dt. So let's then put the value of v. So dx is equal to v, which is 24t minus 3t squared dt. So if we integrate both sides, we find out that x, which is the distance, is equal to integral of 24t minus 3t squared dt. However, the question says that we should calculate the distance from 0 to 3 seconds, and therefore the limits are x equals integral of 0 to 3 of 24t minus 3t squared dt. So let me continue from the top here. So let's go ahead and do this integral. X is equal to, if you integrate 24t, it becomes 24 over 2t squared. Then minus, if you integrate 3t squared, becomes 3 divided by 3t exponent 3. And this is evaluated at 0 and 3. So x is equal to 24 divided by 2 is 12t squared minus, this 3 and 3 can cancel out, so minus t exponent 3 evaluated at 0 and 3. So x is equal to 12 times, I'm putting the upper limit 3 minus 3 cube, then minus another bracket 12 times 0. But however, this is 3 squared. So 12 times 3 squared. So 12 times 0 squared minus 0 exponent 3. So this portion will throw out 0. So x is equal to 3 squared is 9. So at the end of the day, x is equal to 12 times 3 exponent 2 minus 3 exponent 3. So we can factorize 3 exponent 2. So x is equal to, let me factorize 3 exponent 2 out. We are left with 12 times. So this portion becomes 12 minus, if we factorize 3 exponent 2 out, here we'll be left with 3. So x is equal to 3 exponent 2 is 9 times 12 minus 3 is 8. And 9 times 8 is, sorry, I made a mistake. 12 minus 3 is 9. So this is 9 times 9. And 9 times 9 is 81 meters. Find the area bounded by the curve y equals x squared minus 5x plus 6 and the line y equals 0. So the curve is y equals x squared minus 5x plus 6. So we need to sketch this curve. But we know that this curve is of the form y equals ax squared plus bx plus c. And in this case, a is equal to 1, which is greater than 0. And because a is greater than 0, therefore it is a parabola that opens up. So this graph is going to look like a parabola that opens up. Let's find the y-intercept of this graph. For y-intercept, x is equal to 0. So let's find y of 0. It's equal to 0 squared minus 5 times 0 plus 6. Therefore, y of 0 is equal to 6. So we have the intercept 0, 6. Let's also find the x-intercept. For the x-intercept, y is equal to 0 for x-intercept. So it implies that we take all of this function equal to 0. So x squared minus 5x plus 6 is equal to 0. So we need two numbers that when you multiply you get plus 6, and when you add you get minus 5. So you see that those numbers are minus 2 and minus 3. If you multiply minus 2 and minus 3 you get 6. But if you add minus 2 plus minus 3 you get minus 5. So this becomes x squared minus 2x minus 3x plus 6 is equal to 0. So if you factorize x out of this side, it is left with x minus 2. Then if you factorize minus 3 from this side, it becomes x minus 3 equals 0. So in one bracket we have x minus 3, and in another bracket we have x minus 2 equals 0. So the values of x are x equals 2 or x equals 3. So we have the points 2, 0 and also 3, 0 on that graph. Then the next thing is to find the turning point. And for the turning point we need to find y prime of x. So we take this function and differentiate it. If you differentiate x squared, you will get 2x. If you differentiate minus 5x, you get minus 5. And if you differentiate 6, is 0. So the turning point is the point at which y prime of x is equal to 0. This implies that 2x minus 5 is equal to 0, and x is equal to 5 over 2, which is equal to 2.5. So, having gotten the value of x, let's then take this value of x and then put it in y to find the y component of the turning point. So y of 2.5 is equal to, wherever we see x, we put y. Wherever we see x, we put 2.5. Wherever we see x in this function, we insert 2.5. So this is 2.5 squared minus 5 times 2.5 plus 6. So this is equal to minus 0.25. So we also have the point 2.5 and minus 0.25 on this graph. So let's go ahead and then sketch the graph. So the y-intercept on the graph was 0.6, and then the x-intercept were 3.0 and then 2.0, and then the turning point was 2.5 and minus 0.25. So let's use this information to sketch the curve. So this is our x-axis, this is our y-axis. So this is 1, and this part is 2, and then this part is 3, and this part is 4. And on the y-axis we have 2, 4, and then 6. So let's go ahead and plot the point. We have 0.6. So this is the y-intercept. Then we also have 2.0 and then 3.0. Okay, so let's assume this portion is minus 2. So we are going to plot the point 2.5. So 2.5 is the middle of here, and the minus 0.25, it's just a little bit down here. So it's somewhere here. So therefore this graph is going to look like this. So this is the graph. So this is the graph y of x equals x squared minus 5x plus 6. So the second part of the question is we should find the area bound by the curve and the line y equals 0. So the line y equals 0 is the x-axis. So he's talking about this area. So this is the required region where we are supposed to find. So in this case, we see that the line y equals 0 is sitting on top of the curve, and therefore area A is equal to integral of, the limits are 2 and 3, so 2 to 3 of the function, the first one which is on top, and in this case it is 0 minus the second function which is x squared minus 5x plus 6, all of this dx. So area A equals integral of 2 to 3, and let's expand this bracket. It becomes minus x squared, then minus 1 times minus 5x becomes plus 5x, minus 1 times 6 is minus 6 dx. So let's go ahead and do the integration. So A is equal to, this is integral of 2 to 3. So integral of 2 to 3. If you integrate minus x squared, it's equal to minus 1 over 3 x cubed. And if you integrate 5x, you get plus 5 over 2x. And if you integrate 6 minus 6, you get minus 6x. All of this is from, the limit is from 2 to 3, so 2 to 3. We said in the area is equal to integral of 2 to 3 of 0 minus x squared minus 5x plus 6 dx. So let's expand this bracket. A is equal to integral of 2 to 3 of minus 1 times x squared is minus x squared. Minus 1 times minus x is plus 5x. Minus 1 times 6 is minus 6 dx. So let's go ahead and do the integral. If you integrate minus x squared, you get minus 1 over 3x exponent 3. And if you integrate 5x, it becomes plus 5 over 2x exponent 2. If you integrate minus a, it becomes minus 6x. And this is evaluated at 2 and 3. So let's go ahead and substitute the limit. So this is equal to minus 1 over 3 times 3 cubed plus 5 over 2 times 3 squared minus 6 times 3. Then minus another bracket, minus 1 over 3 times 2 cubed plus 5 over 2 times 2 squared minus 6 times 2. So A is equal to 3 exponent 3 is 27. 27 divided by 3 is 9 times minus 1. So this portion becomes minus 9. Then 3 exponent 2 is 9. 9 times 5 is 45. So it becomes plus 45 over 2. Then minus 6 times 3 is minus 18. Minus 2 exponent 3 is 8. 8 times minus 1 is minus 8 over 3. Then 2 exponent 2 is 4. 4 divided by 2 is 2. 2 times 5 is 10. So this becomes plus 10. Then minus 6 times 2 becomes minus 12. So let's go ahead and further simplify. A equals minus 9 plus 45 over 2. You see that 2 times minus 9 is minus 18. Minus 18 plus 45 is 27 over 2 minus 18. Then minus 8 over, minus 8 over 3 plus 10. So 3 times 10 is 30. 30 plus minus 8 equals 22 over 3 minus 12. So 2 times minus 18 is minus 36. Minus 36 plus 27 equals minus 9 over 2. Then minus 3 times minus 12 is minus 36. Minus 36 plus 22 equals minus 14 over 3. So at the end of the day, this is equal to, so this is A. A is equal to, and put this in brackets. So at the end of the day, A is equal to minus 9 divided by 2. Then minus becomes plus 14 divided by 3. And this is equal to 1 over 6 squared unit. A particle starts from rest and its acceleration at time t seconds is given by A equals 2 plus t. Find the velocity of the particle after 1 second. And then B, the position of the particle anytime. So acceleration A is equal to 2 plus t. But we know that acceleration is the same as the v dt. And this is equal to 2 plus t. So let's multiply both sides of the equation by dt. So this dt and this dt cancel. So therefore the v is equal to 2 plus t dt. So you can find v by doing integration. So v is equal to integral of into bracket 2 plus t dt. So v is equal to, if you integrate 2, you will get 2t plus, if you integrate t, you get 1 over 2t exponent 2, then plus c. However, the question says that the particle starts from rest. So if it starts from rest, it means that at time t equals 0, the velocity is 0. So v of 0 is equal to 0. So let's find v of 0. This is equal to, wherever we see t, we replace it with 0. So 2 times 0 plus 1 over 2 times 0 squared plus c. And so v of 0 is equal to 0 plus 0 plus c. So this is c, and this is also equal to 0. And therefore this implies that c is equal to 0. So the velocity of the particle v is equal to 1 over 2t squared plus 2t. The second part of the question says we should find the position of the particle at any time t. We know that position dx dt is equal to the velocity of the particle. So dx dt is equal to, into bracket, 1 over 2 t exponent 2 plus 2t. So let's multiply both sides by dt. Therefore this dt and this dt cancel. So dx is equal to, into bracket, 1 over 2t squared plus 2t dt. So you can find x by doing integration on both sides. So x is equal to integral of 1 over 2t squared plus 2t dt. So let's go ahead and do the integration. So x is equal to, if you integrate t squared, you will get 1 over 3. So it becomes 1 over 2 times 1 over 3 times t exponent 3, then plus 2 over 2 t exponent 2, then plus the constant of integration, since this is an indefinite integral. So let me use this time around a. So x is equal to 1 over 2 times 1 over 3 plus 1 over 6 t exponent 3 plus 2 and 2 will cancel out, t squared plus a. So the question says that the particle starts from rest. So since it starts from rest, at t equals 0, just as we did in the case of the velocity, the distance is also 0. So x of 0 is equal to 0. So let's find x of 0. Wherever you see t, replace it with 0. So this is equal to 1 over 6 times 0 exponent 3 plus 0 exponent 2 plus a. So x of 0 is equal to 0 plus 0 plus a is equal to a. And but we know that x of 0 is 0, which is also equal to 0. So this implies that a is equal to 0. And therefore the position x at any time equals 1 over 6 t exponent 3 plus t exponent 2. But there is something I forgot for the first part of the question, because he said we should find the velocity at after 1 second. So since we found that v is equal to 1 over 2t squared plus 2t, all we need to do is to find v of 1. And this is equal to, it means that wherever we see t, we should replace it with 1. So this is 1 over 2 times 1 squared plus 2 times 1. And this is equal to 1 squared is 1 times 1 over 2 is 1 over 2 plus 2 times 1, which is 2. And this is equal to 5 over 2. And therefore, the velocity is equal to 2.5 seconds. Sketch the curve y equals x squared minus 5x and y equals 2x squared minus 6x on the same axis. With the aid of curve sketch in I, find the area bounded by the two curves. So we need to sketch both curves. So let's start with y equals x squared minus 5x. Let's find the y-intercept. So for the y-intercept, x is 0. So y of 0 is equal to 0 squared minus 5 times 0, which is equal to 0. And therefore, we have the y-intercept as 0, 0. So having found the y-intercept, let's go ahead and find the x-intercept. And for the x-intercept, y is equal to 0. So it means that we should take x squared minus 5x, which is all of this function equated to 0. So we can factorize x out. This is x minus 5 equals 0. So x is equal to 0 or x is equal to 5. So we also have on the x-axis 0, 0. And then also the coordinate 5, 0. Now let's find the turning point TP. To find the turning point, we need to first find y prime of x. So since there are two curves, I would use this as y1 and then this as y2. So y1 prime of x is equal to, we differentiate this curve, which is 2x minus 5. We differentiate x squared, we get 2x. And if we differentiate minus x, 5x, we get minus 5. So the turning point occurs at the point where y1 prime of x is equal to 0. So this implies that 2x minus 5 is equal to 0. X is equal to 5 over 2, which is equal to 2.5. So let's then insert this value of x back into the function y to find the y component of the turning point. So y of 2.5 is equal to, wherever we see x, we replace it with 2.5. This is 2.5 squared minus 5 times 2.5, and this is equal to minus 6.25. So we have the turning point as, so we have the turning point as 2.5 and minus 6.25. Now let's take this function, which is y2 of x equals 2x squared minus 6x. So let's find the y-intercept. And for the y-intercept, x is equal to 0. So y of 0 is equal to 2 times 0 squared minus 6 times 0. And this is equal to 0. So we have 0, 0 as a y-intercept. Then let's find the x-intercept. The x-intercept is equal to, and for the x-intercept, y is equal to 0. So it means we take all of this and equate to 0, which is 2x squared minus 6x is equal to 0. Let's divide through by 2. So we divide here by 2, here by 2, and this partition 2 by 2. So This is equal to 2x squared divided by 2 is x squared minus 6x divided by 2 is 3x equals 0. So we can factorize x out. X minus 3 is equal to 0. So the values of x are x equals 0 and x is equal to 3. And therefore we have 0, 0 and also 3, 0 as the x-intercept. So let's find the turning point. But then to find the turning point, we need to first find y2 prime. And this is equal to, we take this function and differentiate. If we differentiate 2x squared, we get 4x. If we differentiate minus 6x, we will get minus 6. So the turning point occurs at where y prime of 2 is equal to 0. So this implies that 4x minus 6 is equal to 0. So x is equal to 6 over 4, which is equal to 1.5. So we shall then take this value of x and put it back into the original function y2 of x to find the y component of the turning point. So y2 of 1.5 is equal to, let me write it here. So y2 of 1.5 is equal to, the function y of 2 is giving us x squared minus 5x. Sorry, y2 of x is giving us 2x squared minus 6x. So wherever we see x in this equation, we insert 1.5. So this is equal to 2 times 1.5 squared minus 6 times 1.5. And therefore y2 of 1.5 is equal to minus 4.5. So we also have the turning point in this case as 1.5 and minus 4.5. So let's list the points and then go ahead and sketch the graph. So for the first curve, which is y1, we had 0, 0 as the y-intercept. Then we also had 5, 0 as, so for y1 we had 0, 0 as both the y-intercept and also a point on the x-axis, and then 5, 0 as the other point on the x-axis, and then we had the turning point as 2.5 and minus 6.25. Then for y2, so let me write the equation of y1. y1 equals x squared minus 5x, and then y2 equals 2x squared minus 6x. We had 0, 0 as both a point on the x-axis and also the y-intercept, and the other point on the x-axis as 3, 0, and then the turning point as 1.5 and minus 4.5. So let's go ahead and sketch these two graphs. So assuming this is our graph, then let's go ahead and plot the points for y1. So we have 0, 0 and we have 5, 0, and then the turning point is 2.5. So 2.5 is between 2 and 3, and then minus 6.25. So minus 6.25 is a little bit above 6, so it's somewhere here. So this is 2.25 and minus 6.25. So let's go ahead and then sketch the curve. So this goes here. So this curve is the curve y equals x squared minus 5x. So let me write it here. So this curve is the curve y equals x squared minus 5x. So let's sketch for this one too. So we have 0, 0. Then we have 3, 0. So this point. And then the turning point is 1.5, which is between this, and minus 4.5. Minus 4.5 is somewhere here. So we have 1.5 and minus 4.5, which is this point. So this one too is going to look like this. So this is the curve y equals 2x squared minus 6x. So let me cancel it and write it. Y equals 2x squared minus 6x. So we've sketched both curves. Then the question is saying that we should find the region of space bounded by the two curves. So we see that this is the region where that is bounded by both curves. So this is the region of space that we are supposed to find the area for. And if you consider this region of space, you see that the function on top is this function, which is x squared minus 5x, and the one beneath is this. So the area A is going to be the integral of the lower limit to the upper limit of the function, which is the first one is to bracket x squared minus 5x, then minus the second function, the one on top, which is x squared minus 5x, minus the function beneath, which is 2x squared minus 6x dx. But we don't know the point of intercept. We know that these two curves intersect at 0, and they also intersect at this point. So let's equate both functions and then find the points of intersection. One of the functions y equals x squared minus 5x, and the second one is y equals 2x squared minus 6x. So the points of intersection, let's equate both functions. So x squared minus 5x is equal to 2x squared minus 6x. So let's bring both functions to the left hand side. Let's bring these functions to the right hand side. So it becomes 2x squared minus x squared, then minus 6x plus 5x equals 0. So 2x squared minus x squared becomes x squared, and minus 6x plus 5x becomes minus x equals 0. So you can factorize x out. You are left with x minus 1 equals 0. So the values of x are x equals 0 and x equals 1. This means that these two functions intersect at 0 and 1, and therefore our integral for the area is equal to 0 to 1 of the function on top, and the function on top was x squared minus 5x, then minus the function beneath, which is 2x squared minus 6x dx. So let's remove the bracket. This is equal to integral of 0 to 1 x squared minus 5x, then minus 1 times 2x squared becomes minus 2x squared, minus 1 times minus 6x becomes plus 6x dx. So area equals integral of 0 to 1 of x squared minus 2x squared equals minus x squared, then minus 5x plus 6x becomes plus x dx. So let's go ahead and do the integration. So a equals, if you integrate minus x squared is equal to minus 1 over 3x exponent 3 plus, if you integrate x, equals 1 over 2 x exponent 2 evaluated at 0 and 1. So let's put in the limit. A equals, into brackets, minus 1 over 3 times 1 exponent 3 plus 1 over 2 times 1 exponent 2, then minus another bracket, minus 1 over 3 times 0 exponent 3 plus 1 over 2 times 0 exponent 2. So all of this will throw out 0, and therefore the area is left with 1 exponent 3 cube is 1 times minus 1 over 3 is minus 1 over 3. Then 1 exponent 2 is 1 times 1 over 2 becomes plus 1 over 2 minus 0. So A is equal to, let's multiply this function, the numerator and the denominator, by 2. So this is minus 2 over 2 times 3 is 6, and plus, let's multiply the numerator and denominator of this function by 3. So 3 times 1 is 3, divided by 3 times 2 is 6. So minus 2 plus 3 equals 1 over 6 squared units.